In this video, we're going to deal with more with special right triangles. The first one, the case that we've talked about before, is the 45-45 90-degree triangle, also known as the isosceles right triangle. So the markings that we see here in this right triangle show us that we have 45 degrees, 45 degrees, and 90 degrees. We also learned that there was a ratio for the length of the sides, that the two legs would be the same length. Since it's isosceles, we've got those legs that are the same length, and the hypotenuse would be the same as the leg root 2. So I'm using the letter A here, so it'd be A, and then A root 2. And so we will write that ratio as a leg, and then the hypotenuse in this order. And last time in the video I used X's, I used A's here. You can use any variable you want. You want to use a variable that doesn't kind of interfere with the variables that might be in the problem. So I'm using those. So here's an example of a 45-45 90-degree triangle. The legs are 3 and 3, and the hypotenuse is 3 root 2. And here's another isosceles right triangle. This time the legs are 7 and 7, and the hypotenuse is 7 root 2. And here's another isosceles right triangle, and I have the two legs of 5 root 3. So we know that the hypotenuse will be that 5 root 3 times root 2. We can multiply the two radicals. You can always multiply radical by radical, and so you end up with 5 root 6. Here's another isosceles right triangle with legs of 2/3. So the hypotenuse would be 2/3 times root 2. But a better form to write that in is to write that as 2 times root 2 over 3. That's just multiplying the 2/3 times the root 2 over 1. You can use your fraction work with that. And that is the preferred, in my class, that's the preferred way of writing it. I prefer that compared to 2/3 root 2, although they are the same value. Here's another isosceles right triangle, and this time the legs are 7 root 2, and the hypotenuse would be 7 root 2 times root 2. But root 2 times root 2 is just 2, so you get 7 times 2, which is 14, and so the hypotenuse in this isosceles right triangle, or 45-45 90-degree triangle, is 14. Let's look at a few more cases of 45-45 90-degree triangles. Again, I'm showing you so you remember that for these problems that we've got the side ratios of A, and A root 2, or you could say leg root 2. And here's my isosceles right triangle, and I've been given the hypotenuse. Well, the hypotenuse, it's the longest side, and that's the one that is A root 2. So to figure out the length of the legs, I'm going to write that A root 2 equals 8, divide both sides by root 2, and get that A equals 8 over root 2, but we have a radical in the denominator, which is not good form. It's not that that number doesn't exist, it's considered bad form, and so we should simplify this by eliminating that radical, that square root, and we do that by multiplying by itself. So we're going to multiply both numerator and denominator by the radical 2. And we get 8 root 2, and then of course in the denominator root 2 times root 2 is just 2. But 8 and 2, we can simplify that. So 2 goes into 8 4 times, and we end up with A equals 4 root 2. And that A, that's the length of the two legs, and so I put that over there, 4 root 2. So now I have the measures of all three sides of that isosceles right triangle. And here's another isosceles right triangle, and this time the hypotenuse is 15, following the same procedure. This time I'm going to put A's there so we can see more clearly that those are legs would be the A. The hypotenuse, A root 2, is 15. Divide by root 2, and you get A is 15 over root 2. But similarly, we don't like that radical in the denominator, so we multiply by root 2 over root 2. And nothing simplifies in this. A equals 15 root 2 over 2. Since nothing simplifies, that is the answer to A. And we need to put that over in our diagram over here. And so A equals 15 root 2 over 2, or just writing it in that way in the picture. So if you had this as a quiz problem or something, you could just label it in the diagram like that. Let's look at our second case of special right triangles. And our special case deals with the 30, 60, 90-degree right triangle. And so notice that the angles go up every 30. So you've got a 30 degrees, and then the next angle is 30 plus 30, or 30 times 2, 60. And then the right angle is 30 times 3. So you've got a 1, 2, 3 kind of thing going on here of 30, then 2 times 30, then 3 times 30 for the angle measures. But what about the side lengths? The ratios, if we look at the shortest side, the side opposite 30, that's going to be A. The hypotenuse will be twice that, 2A, and then the side opposite the 60 is A root 3. So remember that side opposite the 30 is the short side. So when you look at a 30, 60, 90 degree triangle and it is drawn to scale, that's very key if it's drawn to scale, you'll notice that that will be the shortest side. Where the side that is opposite the 90 degree, which is the biggest angle in that triangle, has got to be the longest side. It's also called the hypotenuse, since it's the side opposite the right angle and the longest side of a right triangle. It's called the hypotenuse. And then opposite the 60 degrees is the third side that, we've talked about a first and then a second, and then we have the third side, not the longest side, it's the side, it's actually the middle length side, but it's the third side, and I always talk about it as the third side, so we remember the square root of 3. So the third side is A, the short side, root 3. Now here's an example of a 30, 60, 90 degree triangle. I'm going to get rid of those angles because they just kind of get in the way, but know that that this picture is drawn to scale and that we have a small angle, that's our 30 degree angle, and the other angle is 60, and we've got the right angle marked there. So therefore on this, I've marked one of the sides 7, well that's the shortest side, and if the shortest side is 7, I'm going to ask you for the other two lengths. Well, the x, so 7 is the short, which would be the A. The x is the hypotenuse, which is twice the short side. And y is the third side, so that would be the short side, root 3. So solving for x, we just plug in our 7, and we get 2 times 7, where x equals 14. To solve for our y, we plug in the 7 there, and we get that it's 7 root 3, so y equals 7 root 3. Look at our next example of a 30, 60, 90 degree triangle, and I've got the 60 degree marked, so you know the other one is 30. In this case, the hypotenuse is 13. And remember, the hypotenuse is always twice the shorter side. And in this diagram, the y is the short side. It's the side that's opposite the 30 degrees. And therefore, x is the third side, which would be A root 3. So first step is to solve for A. Since I know I have the twice A equals 13, I can divide by 2 and get that A is 13 halves, 13 over 2. Well, that's the answer for y. Y is A, so y equals 13 halves. For our x, we just take that A that we just solved for, 13 halves, and we multiply by root 3, and so we write 13 root 3 over 2, and that is our x. Let's look at our last example. We have another 30, 60, 90 degree triangle, and one of the sides is 9. We have to decide which side that is. If we look at that carefully, it's the side opposite the 60 degrees, so that's the third side. The two unknowns, I've got an x. Well, the x represents the shortest side, and y is the hypotenuse. So if we go ahead and mark that with our ratios that we're using the letter A, I've got 9 equals A root 3, x is going to equal the A, and the y is the 2A. So I need to solve for A. So A root 3 equals 9. Divide both sides by root 3. And you get A equals 9 over root 3. We need to rationalize the denominator. So we're going to multiply by root 3 over root 3. And that's going to give us 9 root 3 over 3, but 3 goes into 9 3 times. We need to simplify that, which means that A is 3 root 3, which is what our x is. So we've solved for x. Once we've solved for x, we know that y is just twice that, because it's just 2a, and 2 times 3 root 2 is 3 root 3 is 6 root 3, which is the final answer there. So these are a few more examples of our special right triangles. You might want to replay this and watch it a few times to really get the handle on understanding how to use the ratios of the sides. It doesn't matter how big or small the triangle is. If the triangle has the angle measures of 30, 60, 90, we have this ratio A root 3, and 2A. And if it was a 45, 45, 90 degree triangle, it has the ratios of A, and then A root 2.